Alright, let's solve Spring 2018 Physics 101 Midterm 1 question 2. We are asked to consider a system composed of three masses, M1, M2 and M3. They are tied to each other by cords and pass over a frictionless pulley. There isn't friction anywhere apparently. And the cord is massless. So we have to find essentially the acceleration for all three masses and tensions in the cords. So what will happen in the system? Physically, I expect M3 to go down and pull M1 and M2 together with it. So there will be tensions in both cords. Okay, so let's call those tension force in the first cord T1 and in the second cord T2. To be able to solve this system, I'll draw the free body diagrams for all three masses. Let's start with M1. So what are the forces acting on M1? T1 is pulling it to the right. There is M1G, gravity pulling it down, but that's countered by the normal force on the object. And its acceleration, because these guys are all tied with inextendable cords, they should all move with the same acceleration, which I will actually call A. Let's do the same thing for M2. Just as any massive object, it has a weight, M2G, pulling it down, but that's countered by the table M2, and the second cord is pulling it to the right, the first cord is pulling it to the left, and its acceleration is again in the same direction as M1. How about M3? M3 has its weight, M3G, pulling it down, and T2 pulling it up, and its acceleration is downward. So first part we have already done. Now determine a formula for the acceleration of the system in terms of the masses and G. I have to write Newton's equations for all three objects. Obviously M1 and M2 are not jumping off the table, so I don't have to consider Newton's equation, Newton's second law in the y direction. So what I should actually just do is write M1A, which will be the total force, the net force in the x direction. That will be T1. For the second mass, M2A, the net force will be T2 minus T1. For the third one, M3A, M3G is pulling it down, but T2 is pulling it up. So I've actually written three equations. And how many unknowns do I have? I don't know A, I don't know T1, I don't know T2. So there are three equations, three unknowns. This is enough. We should be able to solve the system of equations. What I will do is I will actually add up all these three equations, which will give me on the left hand side M1A plus M2A plus M3A. All these guys are moving at the same acceleration. So I have T1 plus T2 minus T1 plus M3G minus T2. When I do this addition, all the tensions in the cords go away. So I actually find the acceleration to be M3 divided by M1 plus M2 plus M3 times G. And mass cancels with mass. A and G have the same units, so unit wise both of them are in meters per second square, so that looks like a correct formula. How about finding the tension in the cords? T1 from the first equation above is M1A, which is M1 M3 divided by 1 plus M2 plus M3G. How about T2? if I add the first and second equations, what I find is T2 is m1 plus m2 times A. Times A. So it will be m1 plus m2 times m3 divided by m1 plus m2 plus m3. G. Unit wise, if I look at this, kilogram square divided by kilogram times meter per second square is Newton. Same thing in the second formula, so that seems to be correct. This is quite simple question.